Hello, and welcome to the world of building agentic systems. It's a relatively new space, and you might wonder about the right way to structure and build AI applications. While there is no single correct approach, common patterns such as agents and workflows offer proven structures that can guide your development. Their definitions can be a little bit fuzzy depending on who you ask, and it might not be entirely obvious how they differ or when to choose which. In this video, I'll give you a clear definition, practical guidance on choosing between them, and show how they can even work together to build capable AI-powered applications that work how you expect them to. I'm Alex Booker with Mastra, the TypeScript agent framework. Let's start by defining agents before comparing them to workflows. An AI agent uses a large language model along with tools and a system instruction to work towards an open-ended goal. Guided by the system instruction, the agent dynamically decides how to approach the task, reasons through each step, calls tools, and determines when to stop. To create an agent in Mastra, use the agent class, which, as you can see, naturally follows the definition of an agent. This example is a little bit minimal, but if you've ever used an autonomous coding agent like Cursor, you'll recognize exactly what I mean. It uses tools to search and edit code, and even though you can't readily see it, it's guided by a system instruction to tackle open-ended coding tasks with a high but not perfect degree of success. Another example of an agent is a deep research agent. These agents use a web search tool and are guided by an instruction to issue multiple queries and explore sources thoroughly until they have enough high quality information to answer the user's query. An agent might take 5 steps to complete the task, or it might take 50. It could also take 500 steps and fail to complete the task. And therein lies the potential drawback of agent architecture. Despite their autonomy and power, agents can sometimes take unexpected actions or produce unpredictable results if they finish at all. This is basically fine for coding and research agents because there's always a knowledgeable human in the loop to review outputs, make decisions, and provide the operational oversight required. But say you're building a customer-facing support agent, for example, the tolerance for errors would be far lower. The good news here is that autonomy exists on a spectrum, and in many cases, you can increase an agent's predictability by limiting its tools and tweaking the system instruction to guide it towards narrower, less open-ended goals. This allows you to trade off some autonomy or capabilities in exchange for greater consistency. Nevertheless, the self-directed and non-deterministic nature of agents still requires a certain degree of developer oversight and monitoring through an evaluation system known as evals. By contrast, an AI workflow is a system whereby large language models are orchestrated through predefined paths to complete well-defined tasks. The number of steps and the stopping condition are fixed and fully controlled by you, generally resulting in more predictable and consistent behavior. You can create workflows in Mastra by breaking tasks into steps and composing them with create workflow. The most straightforward example is running steps one after another in a chain. You can also branch, loop, run steps in parallel, or even pause a workflow to accept input from a user before resuming. Each step uses a large language model to process text, make decisions, or generate content before passing the results to the next step, and you can even use different models for different tasks. For example, if you decide the cost of iterating on a customer support agent outweighs the benefits, you might adapt a workflow architecture instead. In this setup, step 1 categorizes incoming questions, then branches based off of the topic, perhaps generating a response from a knowledge base for obvious issues, or emailing an account manager with sensitive sales queries. As you can now appreciate, workflows and agents can both tackle similar problems. The key difference is usually who's in the driver's seat. In a workflow, you set the steps and logic in advance, steering the process yourself. In an agent, the model chooses its own path based on context. That means agents are better suited for unstructured tasks where you can't reliably orchestrate the steps up front, and they have the potential to be highly agentic. Workflows are still somewhat agentic in that each step can harness the reasoning and generative abilities of a large language model, but they operate within a structure that you define, making them behave more predictably, enabling you to go into production with more confidence. Despite the title of this video, which kind of poses workflows and agents as rivals, it turns out neither approach is actually better in an absolute sense. Which architecture you adopt depends on what works best for what you're building, balanced against the trade-offs you're willing to accept. And did you know you can actually use workflows and agents together? For example, a workflow might lean on an agent's strength to understand unstructured data by calling it to interpret a PDF and extract key insights before passing them to the next step. At risk of bending your brain a little bit, an agent can also invoke a workflow via a tool. For example, an autonomous coding agent might take advantage of a workflow's predictability to check the code it generated for vulnerabilities, such as hard-coded secrets or injection risks. This workflow could involve running different checks for different issues in parallel, then aggregating the results before returning control to the agent. Perhaps now you're starting to see that these are, in a way, building blocks. You can combine them in different ways. Sometimes you can arrive at the same answer using a workflow or using an agent. You've just maybe, the agent might be more constrained by a very specific system instruction. You can limit its max tool calls. You can limit the tools it has available. You can make it behave just as deterministically as a workflow in some cases. Equally, a workflow could call out into a large language model, do some advanced reasoning, and behave more autonomously. It's hard to visualize and explain succinctly, but I think you're starting to get the idea that this is a new industry. It's hard to say what is a best practice because everybody, all the smartest minds, I'm not one of them, are trying to figure it out. And you're really just kind of focusing on building something practically successful. It's easy to get caught up in theory. It's easy to caught up in definitions like, is this an agent or is it a workflow in disguise? Is it a workflow or an agentic workflow? You can read 10 blog posts and get 10 different answers. The question I would argue is the most important is, does it work, and does it work well in practice? It's quite a liberating attitude because everyone seems to have a different definition for these things anyway. Now that you've got a clearer understanding of how agents and workflows relate, the next step is to dive into the Mastra documentation and build an awesome agentic system.